Hello everyone, welcome back to my class. For today's lesson, you will learn a new chapter, chapter 3, force. And at the end of this chapter, you should be able to understand the concept of force and understand the concept of moment of a force. So what is force? Force is defined as an action which will alter the state of motion of a body in a straight line. In other words, a force is a push or pull upon an object, resulting in the object interaction with another object. So the SI unit of force is Newton. There are so many examples of force in everyday life. For example, a car that moving on a road suddenly stops, a woman pulls the door of the room, and etc. Okay, the next topic is about the effect of a force. So there are 5 effects of a force. Okay, effect number 1. A force can change the size of an object. Okay. Number 2. A force can change the shape of an object. Number 3. A force can change the state of motion of an object. Number 4. A force can change the direction of an object. And number 5. A force can change the speed of an object. Okay, I give you an example. Untuk contoh yang kedua ini, a force can change the shape of an object. Let's say you have aluminium tin. So when you crash the aluminium tin, kamu perhatikan tin akan kemek. So disebabkan tindakan daya tadi kan, kamu crash tin aluminium tadi. So you change the shape of an object because of the force that you use to crash the aluminium tin. Ini contoh yang pertama. Okay, kita ambil contoh yang kedua. For example, a force can change the speed of an object. Macam mana? Contohnya, bila kamu memandu bawa kereta, suddenly you press the car brake. Kamu tekan brake. So bila kita tekan brake, kita apply daya yang menyebabkan kereta menjadi perlahan. So in that case, you change the speed of an object because of the force that you use to press the brake. Okay? So next you will learn about Newton's first law and Newton's second law. So what is the Newton's first law? The Newton's first law states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. Okay, for example, bila kamu main bola, kamu tendang bola, bola itu akan bergerak, akan kekal bergerak, melainkan ada tindakan daya daripada yang lain yang menghentikan pergerakan bola tersebut. Itu contoh bagi Newton's first law. Okay, the object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. Contoh lain macam buku lah. Bila kamu letak buku atas meja, buku itu akan kekal dalam keadaan rehat, melainkan kamu ambil buku tersebut. Newton's second law pula menyatakan the force acting on an object is equal to the mass of that object times its acceleration. So basically, Newton's second law is related to the formula of F equal to ma, where m is for the mass, which is measured in kilogram, and acceleration is in meter per second square. Alright, kita akan tengok contoh soalan yang melibatkan F equal to ma selepas ini. Okay, we move into the next slide. A net force of 25 Newton acts on an object which has a mass of 2 kg. What will be the acceleration of the object? So in this question, we want to find the acceleration of the object. Okay, make sure that all unit using SI unit so that you can continue with the calculation. So for this question, the force is already in SI unit, which is 25 Newton, and the mass is also in SI unit, which is equal to 2 kilogram. So we use the formula of F equal to ma. Rearrange this formula, so you will get A equal to force over M. Alright, susun semula formula ni. So A equal to F over M, 25 divided by 2 kilogram. So the answer is 12.5 meter per second square. Okay. Next example. How much horizontal force is required to accelerate a 250 kilogram box at 4 meter per second square? So once again, you have to check the SI unit for all information. So for this question, the mass in kilogram, okay, and the acceleration is also in SI unit. So you can continue with the calculation. So in this question, we will use F equal to ma. So we want to find the force. So force is equal to mass 250 kilogram multiplied with 4. Okay, so the answer will be 250 multiplied with 4 equal to 1000 Newton. Alright. Okay, next example. Example 3. A vehicle has a mass of 1000 kilogram. So the driving force created by the engine is 2000 Newton. Calculate the acceleration caused by this force. Okay, so please check all the information. So here we have mass is equal to 1000 kilogram using the SI unit. Okay, so the engine is 2000 Newton also using SI unit. So you can continue with the calculation. So here we use the formula of F equal to ma. We want to find the acceleration. So we rearrange this formula, so you will get A equal to F over M. So 2000 divided by 1000 kilogram is equal to 2 meter per second square. Okay. Example 4. Find the acceleration of the object given in the figure below. Okay, find the acceleration given in this diagram that the car has 500 Newton force and the mass is equal to 25 kilogram. Okay, so in this question we will use the formula of F equal to ma. Rearrange this formula, so you will get A equal to F over M. So F is equal to 500 divided by 25, and the answer is 20 meter per second square. Alright, so the next topic is involving forces. 3 types of cases. Basically, it involves 3 types of formula. So all these formula are based on a different cases or situation. For example, we have F equal to mg, F equal to mg sin theta, and formula number 3 is F equal to ma. Alright, so 3 formula ini kita gunakan pada 3 keadaan yang berbeza. So please pay attention. Bila masa kita akan gunakan formula-formula di atas ni. Okay, saya akan bagi contoh selepas ini. First, we will look to the first formula, F equal to mg. The normal force that acts against gravity. So the normal force is the component perpendicular to the surface of contact because of their weights. And the magnitude of the force is the same and the direction of the force is opposite in the direction with the applied force. So, untuk lebih jelas, kita akan tengok contoh di sini. Example 1. What is the minimum force needed to lift a 15 kg object? So, kita nak angkat kotak objek ini yang mempunyai jisim 15 kg. So, for this question, we will use formula number 1, which is equal to F equal to mg. So, once again, please check your information. Make sure all information are using SI unit. So for this question, the mass is already in SI unit. Mass is equal to 15 multiplied with the gravity value 9.81. So the final answer will be 147.15 Newton. Alright. So the next question is, what is the weight of a 800 kilogram object? So we want to find the weight of an object. So here we will use the formula of W equal to mg. This is the formula to find the weight. So 800 multiplied with gravity value, which is equal to 9.81. So the final answer will be 7848 Newton. Okay. So the next question is, an object of mass 2 kg is lying on the table. Calculate the normal force acting on the object. So we want to find the force acting on the object. Once again, we will use the formula of F equal to mg. So 2 multiplied with 9.81 equal to 19.62 Newton. Alright. So untuk soalan tadi tu, kita gunakan formula F equal to mg. Untuk situasi yang seterusnya, kita akan guna formula yang kedua, F equal to mg sin theta. So force acting against inclined plane, F equal to mg sin theta. It says that the force acting upon an inclined plane involves 2 or more forces which are not directed in opposite direction. Okay, thus one or more of the force will have to resolve in perpendicular component so that they can be easily added to the forces acting upon an object. So this process involving resolving the forces acting into 2 components, one directed parallel to the inclined surface and the other directed perpendicular to the inclined surface. Okay. Kita tengok slide yang seterusnya. Okay, untuk yang ini, kamu boleh imagine kotak yang digerakkan melalui suatu permukaan yang condong. So, situasi yang kedua ini, yang melibatkan formula yang kedua, iaitu F equal to mg sin theta, adalah apabila suatu objek itu digerakkan melalui suatu permukaan yang condong. Dan permukaan condong itu menghasilkan sudut. So the parallel component of the force of gravity is not balanced by any force. So the object will accelerate down due to an unbalanced force. So basically, the formula that you will use for this situation is force equal to mg sin theta. Okay. Force equal to mg sin theta to calculate the force that acts on the inclined plane. So I'll give you an example. A 5 kg mass is placed on an inclined plane at 20 degrees. Calculate the weight of the object and the minimum force needed to pull the object along the plane. So, kamu boleh tengok di sini diagram ni, kotak ini ditarik ke atas melalui satu permukaan yang condong. So, what is the weight of the object? So, we use the formula of W equal to mg, 5 multiplied with 9.81, so equal to 49.05 Newton. That is the weight of the object. Question number 2, the minimum force needed to pull the object along the plane. So kita nak kira daya yang digunakan untuk menarik objek ini melalui suatu permukaan yang condong. So for this question, we will use the formula F equal to mg sin theta. So in previous question, you already calculate the weight of an object. So to find the force needed to pull the object along the plane, so we multiply the weight, which is equal to 49.05 sin 20 degree. The final answer will be 16.78 Newton. Alright class, we move into the next slide. The third situation that involving the third formula, force equal to ma, force against inertia. It is actually related to Newton's second law. So for this situation, we refer to example on the subtopic of Newton's second law. We already discussed it in previous slide. So I will show you once again the force that related to the inertia, which is the Newton's second law. So this is the example for that situation. F equal to ma. Okay, F equal to ma. Okay, for the next topic, we will learn about weight and mass. So what is the difference between weight and mass? Okay, berat dan jisim. So weight is a measure of how strong gravity pulls on that matter. For mass is a measure of how much matter an object has. So in terms of definition, this is the difference between weight and mass. So mass and weight ni, kalau kita tengok perbezaan due to gravity, kamu boleh tengok contoh di bawah ini. So orang ni, kalau kamu tengok ada orang ni berada di bumi. So the weight on the earth is around 490 Newton. Beratnya 490 Newton orang ni semasa berada di bumi. Tetapi apabila dia berada di tengok yang sebelah ni, bulan, the weight will be around 81 Newton. So kenapa berbeza? Ini disebabkan di bumi tarikan gravitinya tidak sama dengan di bulan. For example, in Earth, the gravitational value is equal to 9.81. Alright. Tetapi apabila dia pergi ke bulan, tarikan graviti bulan lebih rendah daripada bumi. Disebabkan itu, the weight on the moon is lower than on the earth. Okay, around 81 Newton on the moon. Disebabkan tarikan graviti yang tidak sama. Jadi berat pun berbeza. Okay, tetapi in terms of mass, jisim, let's say that this person has 50 kg mass. Bila dia berada di bumi atau di bulan, jisimnya akan tetap sama 50 kg. Kenapa? Because the mass does not influenced by the gravity. Okay, mass ini tidak dipengaruhi oleh tarikan graviti. Tidak seperti berat dipengaruhi oleh tarikan graviti tempat tersebut. Okay, untuk lebih jelas comparison of mass and weight, kamu boleh tengok jadual ini. Mass and weight, kita ada 1, 2, 3, 4, ada 7 perbezaan antara mass and weight. In terms of definition, mass is a property of matter. The mass of an object is the same everywhere. But for weight, the weight depends on the effect of gravity. Weight varies according to location. Ini saya sudah terangkan tadi. Weight varies according to location. Seperti kalau di bumi dengan di bulan memang beratnya akan berbeza. disebabkan tarikan graviti berbeza. So mass can never be zero, but weight can be zero if no gravity act upon an object. For example, as in space. Alright. Perbezaan yang ketiga, mass does not change according to location. Okay, but weight increases or decreases with higher or lower gravity. Okay, mass is a scalar quantity. Because of that, it has a magnitude. But weight is a vector quantity. It has a magnitude and is directed toward the center of the earth or other gravity well. Next comparison, mass may be measured using an ordinary balance, but weight is measured using a spring balance. Mass usually is measured in grams or kilogram, but weight often measured in Newton, which is also the unit of force. Mass is a base quantity. Alright, mass is a base quantity, but weight is derived quantity. Okay, that's all for today's lesson for part 1 of chapter 3 force. We will continue again in part 2 chapter 3 force.